Hi everyone. So once again, I'm going to do my best to be as brief as I possibly can, because again, I could gush on about all this stuff for quite a long time. We got this equation a little while back, not too far back, but a little while back, and I think I'm also going to be posting a video that kind of explains this, as well as length contraction a little more, right? Length contraction. That the length of something is equal to the square root of 1 minus v squared over c squared multiplied by L p. So these p's that I'm using, some other, I think some of the videos I'm showing you, he's using naught, t naught, and L naught. Some places use tau, for this or whatever. These are proper time and dilated time, and where this is proper length and contracted length, right? So we got time dilation and length contraction. Those are all relativistic things, yeah. So as you've also probably seen with this v squared over c squared, often v squared over c squared is seen so often that we just call it beta. So sometimes you'll see this. This will be written as the dilated time is equal to the proper time divided by the square root of 1 minus beta squared. And same idea with length. But again, we see also this term right here, that this 1 over... We often see this term 1 over the square root of 1 minus v squared over c squared, or beta squared, so often that we just call it gamma, because we don't want to write that over and over and over again, so we say that whole thing is gamma. That's why oftentimes you'll see physics equations that seem like, oh, that's a really simple equation, and then, oh yeah, gamma means all this means all this is this many constants, and yeah. So that rewrites basically this idea into that the dilated time is equal to gamma multiplied by the change in proper time. And again, proper time is basically the time established at those two events. So if you were there at two events, if you were like, at those two events, then you're considered proper time. That says it's not like suggesting that thing is like official or anything like that. It's just with respect to those events, those are considered if they're simultaneously happening at where that particular perspective was. So again, I'm hoping some of the videos I show kind of elaborate that a little more. And then we also get then that length contraction. Length contraction is proper length divided by gamma. Okay. So, and then we got from the last video, hopefully you saw, is that momentum. Let's see if I can get a little cleaner slate here, is that momentum was redefined in relativistic effects because it's not just mv, or rest mass multiplied by v, which is how we've been defining it so far. It's the mass, which in relativistic momentum we say is rest mass, multiplied by v. That's not what momentum is anymore. It is gamma times the rest mass times v. And again, it was argued that you could say that this whole thing is mass, and you get that old-fashioned momentum back there. But again, this is gamma 1 divided by 1. So gamma 1 divided by the square root of 1 minus beta squared, or v squared over c squared. That is, this ends up being really what momentum is. I tend to kind of go with this thing, because I think this is kind of a bit of a misconception that people have. Oh, it's just mv again, but that mass term has all that embedded in it. And you see something similar where people will often, because another thing that comes out of Einstein's equation, you all can probably guess. Yeah. That's the energy mass equivalence right there. However, this often bugs me as well, because I mean, really, what this is saying, when people talk about this is kind of what they're saying, and this is actually rest mass. So energy equals rest mass times the speed of light squared. And this is rest energy then. So if you are something, if you are anything, if you have mass, you have energy. What is your energy equal to? It's equal to your mass multiplied by the speed of light squared, and that gives you energy. Or, well, if we were to annihilate you, that would give you you would be converted into that energy. I don't feel like annihilating any peoples anytime soon. So yeah. So, but just by existing, you have inherent amount of energy. And literally what Einstein's saying here is that mass can be converted into energy, and energy can go right back into mass. They are exactly the same thing. They only differ by this speed of light term squared. So you can probably imagine if you have a little bit of mass, if you have any little bit of mass, multiply that by c squared. C is a pretty big number. That's 3 times 10 to the 8 meters per second. Square that sucker, oh my goodness, that becomes a lot of energy. So you can, if you want to calculate your energy, by all means go do so. Convert your weight into mass, multiply it by c squared, and boom, you got your energy. Pretty cool. Yeah. However, that's just the rest energy. That's just the rest energy right there. What would be the total energy? What would be the total energy? Your total energy, well, that would be, well, gee whiz, I wonder what it'll be. It's going to be gamma times your rest mass times c squared. That would give you your total energy, because if you are moving, that's where that gamma term comes in, because remember, it's 1 over the square root of 1 minus v squared over c squared, or beta squared. So if you start moving, that would give you even more energy on account of that. And again, often we say that this whole thing, we kind of redefine mass, and that's what it gives you. So really, we're talking about your total mass, c squared, and that would be your total energy. So I'm just gonna write down E equals I'm gonna say E. E means total energy. E, total energy. Because now I'm gonna set you guys up for a bit of a derivation. Hopefully it's not too bad. Now we're gonna say, okay. We're going to say m naught is rest mass, and gamma is 1 over the square root of 1 minus v squared over c squared. You're free to use beta too if you'd prefer to use that. So you're going to use these equations here, these equations. So the first one's the momentum equation. Momentum equals gamma m naught v. So you start with that. Other one now is going to be energy equals gamma m naught c squared. Remember, this is total energy. Total energy. Don't forget that. That's total energy. So you're going to use this as well. And I think that's all you need. On top, you might want to throw this in your back pocket as well. You might need that term as well. That's what I did when I derived it, but there's multiple ways to do this. And basically what I want you guys to do is using these ideas is to get to this relationship, that the total energy squared is equal to the momentum squared times the speed of light squared plus mass squared, that's the rest mass, your rest mass squared times the speed of light, not squared, to the 4th power. So see if you can do that. So again, you're starting with these two ideas and then get to this. So see if you can do that. Again, this might come up along the way, and post it to the discussion board. So good luck, and we'll talk more about this total energy equation a little bit later, especially next week when we talk about photons and light, and light having momentum and things like that. Yay! All right. Good luck. See ya. Bye.